Alright, so area of composite figures. Composite figures are just made up of multiple figures into one. So think of an ice cream cone. Okay? The bottom is a triangle and the top is a circle. That's a composite figure. What we're going to do today is we're going to find the area of the whole composite figure by using the area addition postulate. So pretty much all we're going to do is we're going to find the area of one figure and add it or subtract it to the area of the other figure to find the total area that I have. So, example 1, we want to find the area of this. So, what you're going to do with composite figures is you're going to break it up into 2 or more different figures. With this one, there's a few different ways you can do it. Okay? There's not necessarily a right or wrong way. I could cut it into 2 rectangles this way, or I could cut it into 2 rectangles this way. It does not matter which way you do it, you will end up with the same area. Okay, so I'm going to do it this way. Alright, so we're going to label this number 1. Oops. Oh my goodness. And this will be number 2. So to find the total area of my figure, we're going to take the area of rectangle 1 and add it to the area of rectangle 2. Okay? So, my total area, let's write out our area formulas. What is the formula for the area of a rectangle? Base times height. Plus, what's the area of another rectangle? Base times height. So we're going to do base times height of the first one plus base times height of the second one. Alright? So my first one, this rectangle, what is the base length of this rectangle number 1? 15 is the base. Okay? And then somebody else, what's the height of this rectangle? 12. Good job. Alright, so there's the area of the first one. Now we need the base and height of my second one. Alright, somebody else, what's the base of this second rectangle? 27 is the base. Do they explicitly give me the height? No, but I can find it. Okay, because this length is my height. If I know the whole thing is 21, and this piece is 12, I can take 12 from 21 to find this. So 21 minus 12 gives me 9. So the height of my second rectangle is 9. Alright, so let me just do the multiplication. So you're going to do 15 times 12, which gives you 180. And then 27 times 9, which gives you 243. And then when you add those together, your total area of this figure is 423 centimeters squared. Easy enough. Questions on example 1A? Alright, example 2. So they already split it into 3 figures for me. They split it into a rectangle here, or excuse me, a triangle here, a rectangle here, and then a semicircle here. Okay? So the area, the total area, I'm just going to put a little t this time, is going to be the area of my triangle plus the area of my rectangle plus the area of my half circle. Okay? So, my total area formula. What is the formula for a triangle? One half base times height plus, what's my area for a rectangle, guys? Base times height. And then, what is the area for a circle? 2 pi radius is the circumference. What's the area formula? Pi r squared. So if I'm doing half of it, it's going to be half of pi r squared. Alright, so that means I need the base of my triangle, the height of my triangle, the base of my rectangle, the height of my rectangle, and the radius of my half circle. So, for my total area, that's 1/2. Do I have the base of my triangle? No. Do I have the height of my triangle? No, but I can find it. Do you have a question? Okay. Okay, so I need the base, and I can find the height, because this length over here is 3, which makes this 3. So when you take 3 from 7.8, you get that the height of your triangle is 4.8. Okay, so we have the height of the triangle. Plus, and again, I'm going to solve for everything else, the base of my rectangle I don't have, because this is still the base. But the height I do have is 3 plus 1/2 pi, and then my radius. I don't know my radius because the radius goes from the center of the circle out to the side. I need to find it. So notice that the pieces of information that I need all pertain to this length right here. Because remember, opposite sides are equal. So if I can find this length, then I know the base of my triangle, I know the base of my rectangle, and I can cut it in half to find the radius of my circle. So, this is a right triangle. We have 4.8 right here, and I have the hypotenuse, which is 10.2. So what am I going to do to find the length of the base of that right triangle? The Pythagorean theorem. So it's going to be a squared, which is 4.8 squared, plus b squared, which we don't know, is equal to 10.2 squared. So 4.8 squared gives you 23.04, plus b squared equals 10.2 squared, which is 104.04. When you subtract that 23.04 from both sides, you get that b squared equals 81. And then you square root both sides, and what's the square root of 81, guys? 9. So that means this length down here, this is 9. So now I have the base of my triangle. The base of my triangle is 9. I now have the base of my rectangle. That is also 9. And then if it's 9, what is the radius? 4.5. How did you get that? Yep, this whole thing is 9. But when you cut it in half, it's 4.5. Alright, so all I had to do was find that information, and it helped me find all my other missing pieces. Alright, so now what I'm going to do is I'm going to go ahead and add this up and plug it in. So the area of my total figure is 1/2 9 times 4.8. That gives you 21.6. We're adding that to 9 times 3, which is 27, plus 1/2 pi times 4.5 squared. Now they want us to round to the nearest tenth, so this is how you're going to do it, guys. 4.5 squared divided by 2, so that gives you 1/2 of 4.5 squared. Then you have to take that and multiply it by pi, and when you round to the nearest tenth, you should get 31.8. All right? Yes. Sure, yeah. So you're going to take your radius, which is 4.5 squared, which gives you 20.25, and then you have to divide by 2 or multiply by 1/2. So when you divide by 2, that gives you 10.125. But then you still have this pi. So then you have to multiply by pi and press equal. Okay? All right, so then you add all this up. So your total area is going to give you 80.4 feet squared. This is a really good lesson to review all of your area formulas if you have forgot them. Questions here? All right. Anybody need more time to copy this down? All right, next example. Now, we're taking things out of our figure, okay, because I only want to find the shaded region, so I only want to find the blue area of this figure. You're still going to follow the same thing. So I'm going to find the area of the total figure and then subtract this out. So to find my total area, or my area of the blue shaded figure, I'm going to take the area of my whole rectangle and subtract the area of the triangle. All right? Anybody confused on why I'm doing this? Okay, because I want only this area, so if I find the whole thing and take that out, I'm left with just the blue. So the area of my blue figure, what's the formula for the area of a rectangle? Base times height. Minus my area of a triangle. What's the formula for the area of a triangle? One half base times height. No, because you're forgetting this 18. All right, so the area of the blue. The base of my rectangle is 36. The height of my rectangle is 18. Minus 1/2. What is the base of my triangle, guys? 36. Because remember, opposite sides are equal, so this length is 36. Then the length of my base of my rectangle is 36. Multiply that by 9, and there you go. So now you just multiply this out and subtract. So 36 times 18 gives me 648. Minus 36 times 9 times 1/2 gives me 162. So when you subtract those, the area of my blue figure is going to be 486 meters squared. Okay, over here, I want to find only the yellow region. So for the area of the yellow region, what is the whole entire figure if I didn't take anything out? What shape is that, guys? A rectangle. So I'm going to find the area of my rectangle and then subtract. This is called a what? Semicircle. This is called a what? If I put them all together, what do I get? An entire circle. So instead of subtracting 2 semicircles, I'm just going to subtract an entire circle, because they are going to have the exact same radius. So if I just subtract the whole circle, that takes out both sides. All right? So for the area of my yellow figure, I'm going to take the area of my rectangle, which is base times height, minus, and then what did we say the area of a circle was? So 1/2 pi r squared is a semicircle. So if I'm doing the whole thing, it's just pi r squared. Does that make sense?
Yeah.
Okay. So minus the whole thing, which is pi r squared. And again, I could do 2 semicircles, but when you put them together, you get the whole circle, so you're ending up doing more work. Alright, so the area of my yellow figure is the base of my rectangle, which is 33, times the height of my rectangle, which is 16, minus pi. Okay, this whole diameter is 16. So that means the radius, half of it, would be 8. So then it's 8 squared. So the area of my yellow figure is going to be 33 times 16, which is 528, minus 8 squared, which is 64, and then you have to multiply that by pi, which gives you 201.1. So when you subtract that from 528, you're going to get that the area of your yellow figure is equal to 326.9 feet squared. Alright, so composite figures are pretty easy. If you set them up kind of the way I'm doing it, where you make it a problem and then just work it vertically like this, it's going to be much easier. Okay, because you'll have everything where you need it instead of finding 5 different areas and then adding or subtracting them. If you just leave them together, it'll make your life easier. Alright, so any questions on example 2? Alright, now we're going to do something even easier. We're going to estimate our area. So, with estimations, your answer might be a little bit different than mine depending on how you count these. Okay? So, there's a few different ways you can solve for this. You can cut it up into different figures. So I could cut it up into a triangle here, an estimated triangle. I could cut this into a rhombus. I could cut this into a trapezoid. And then I could cut this into another triangle. And that's going to estimate all my figures. Or, even easier, I can just eyeball it. I can say this is covering about half of it. This is covering about the whole thing. This is about half. This is about half. This is a whole. This is a whole. This is a half. This is half. A whole. A whole. Half and half. And then just add it all up and there's your estimation. So this is 1, 2, 3, 4, 5 whole pieces. And then 1, 2, 3, 4, 5, 6, 7 half pieces. So 7 half pieces is 3.5 plus my 5 whole pieces. This is about 8.5 centimeters squared. And the reason I know it's centimeters is because each unit is 1 centimeter. If you had cut it into those 4 figures like I told you and found the area of all of those, you would have gotten about 8.5 as well. Alright? I'm going to suggest cutting it into half pieces and whole pieces instead of like 3/4 pieces or whatever. If it covers most of it, make it a whole like we did here. If it covers about half, make it a half here. Questions on that? Alright, then the last 2 examples. We want to classify this figure and then find the perimeter and area of it. Alright, so first of all, if I classify this figure, it is a rectangle. I think everybody can easily see that this is a rectangle, which means opposite sides are congruent. And then, what would be the hard way to find the distance between this piece and this piece? What would be the hardest, most annoying way I could find that? What formula would I use to find here to here? What What formula would be the worst possible way to find that distance from A to B? The distance formula. Remember, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. I personally don't want to do that for the sides. So instead, because we're so good at the Pythagorean theorem, we're going to do it like this. You're going to create right triangles around your figure. And then what we're going to do is notice that the sides of your rectangles, or the sides of your rectangle, lies on the hypotenuse. Okay? So, I can easily find what the length of the two legs are by just counting. Because, what is the length of this leg over here? 3. You just count. 1, 2, 3. So this length is 3. What about this leg? 1, 2, 3, 4, 5, 6. That leg is 6. So because I know this leg is 3 and this leg is 6, I can do the Pythagorean theorem to find the length of AB. So that's what we're going to do. So first we're going to find the length of AB. So we have 3 squared plus 6 squared equals the length of AB squared. So 3 squared is 9, plus 6 squared is 36. That's the length of AB squared. Add those together, you get 45 equals AB squared. So you take the square root of both sides to find that the length of AB is equal to the square root of 45. And again, because it's a rectangle, that means opposite sides are congruent, which means I now know that the length of DC is also the square root of 45. Do you guys think that was easier than doing the distance formula? I hope so. Alright, we're going to do it again over here. I need to find the length of BC. So what is the length of this leg? 2. What about this leg? 4. So then now I'm going to do this leg and this leg to find the length of BC. So I'm going to find BC over here. So that is 2 squared plus 4 squared equals the length of BC squared. So 2 squared is 4. 4 squared is 16. That's equal to the length of BC squared. So 20 equals BC squared. You square root both sides, and you get that the length of BC is equal to the square root of 20. And again, because opposite legs are congruent, now I know the distance between all my points. So now I can find my perimeter, and I can find my area. So, for my perimeter, you add up all the sides. Alright, so I'm going to go ahead and put those radicals into decimals, rounded to 2 decimals. So I'm going to do 45 square root, which gives me 6.71. So this length AB is 6.71, plus the length of BC is the square root of 20, which is 4.47. Then down here is the square root of 45, so again that's plus 6.71. And then this length is the square root of 20, which is 4.47. So my perimeter is going to be adding up all those sides. And when you add them all up, and we're going to round to the nearest tenth, you get 22.4 units squared. Alright, so anybody confused on how I got the perimeter? Okay, now we want base times height. So the base is square root of 45 times my height of my figure, which is the square root of 20. When you multiply radicals, you multiply the numbers inside. So the square root of 45, or 45 times 20, is going to give you 900. So the area is the square root of 900, which is a perfect square, which gives me that my area is 30 units squared. Alright, so that's going to be the hardest thing we do today. And all you have to do is the Pythagorean theorem twice, and then add up all the sides, and then multiply base times height when it's a rectangle. Is anybody confused on how I did example 4? The way that I found this distance between these 2 points, you can now use all the time when you are given given 2 points. So let's say they say find the distance between this point and this point. Okay, this dotted line that I made. Just create a right triangle, do the Pythagorean theorem, and now you know the distance between the dotted lines. Okay? Alright, last one. We want to find the area of this polygon. Alright, well, there's not a way that we can identify it. So, what we're going to do is we're going to find this entire area. Okay, actually, let me do it with this. I'm going to find this entire area of my red figure, and then just subtract out the triangles, and when I subtract out the triangles, I'll be left with just the green figure. Does that make sense, guys? If I find the whole red figure, and then cut out A, B, C, and D, now I'm left with just the green figure. Okay, so step 1 was to draw the rectangle around it. Step 2 is going to be to find the area of all the triangles. Okay, so the area of triangle A is just 1/2 my base times my height. So if I look at area at triangle A, what is the base of this triangle? 5. All you have to do is count. 1, 2, 3, 4, 5. Okay, so the base of this triangle is 5. What is the height of this triangle? 4. So the area of triangle A is 10. I'm going to put a 10 in here. Okay. Now I need to find the area of triangle B. So that's 1/2. What's the base of triangle B? 3. What's the height of triangle B? 2. So that area is just 3. Now we need to find the area of triangle C. So that's 1/2. The base of triangle C is what? 2. What's the height of triangle C? 5. So that's just the area is 5. Finally, we need to try to find the area of triangle D. So that's 1/2 the base, which is 6, times the height, which is 3, which gives me 9. So now that I have the area of all these triangles, I'm going to take the area of the rectangle and subtract it from the area of all the triangles. And that's going to give me the area of my green figure. Anybody confused on what I'm doing here? Finding the area of my red figure and subtracting all of these triangles to find my interior. Okay? So the area of my rectangle is just going to be base times height. So the base of this is 1, 2, 3, 4, 5, 6, 7, 8 times the height, which is 1, 2, 3, 4, 5, 6, 7. And we're subtracting that from 9 plus 5 plus 3 plus 10. Well, I'm subtracting all of them, so minus 9, minus 5, minus 3, minus 10. All right, so 8 times 7 is going to give me 56, minus the 9, minus the 5, minus the 3, and minus the 10. So when you subtract all of those, you get that your area of your green figure is equal to 29 units squared. All right, so if you can make an entire large figure and then subtract each little piece from it, that's another way to find the area in a graph. So what I want you guys to do is go ahead and look at your homework really quickly and look at number 5 and number 6. It's hard to tell with the coloring that you guys see on your paper, okay? But in number 5, you are taking the triangle out of that. And in number 6, you are taking the circle out. Okay, and then on the back, the easiest way to do number 10 is to find the area of the whole triangle and take out that little piece on the bottom. All right? So if you have questions, let me know. Otherwise, go ahead and get started.